All right, everybody. So we met one-to-one functions, and now we get to meet what actually is an inverse function. So if f is a one-to-one function, then we'll call another function g the inverse of f if we have the following two things about these compositions. So if f of g of x equals to x, and if g of f of x equals to x. So this first one is for all x in the domain of g, and the second one applies for all x in the domain of f, because we start with f first there. So really, how can we read this? The idea is that whatever g does to x, f will undo that and take you just back to x. So you start with x, you do g to that, and then f undoes whatever g did. And similarly, going backwards, if you start with an x in the domain of f, and you do f of that, then following that with g will undo whatever f did and just take you back to the x that you started with. So for this reason, they don't normally write g as the inverse of f. They like this notation that the inverse of f is written with f with a sort of -1 up here. Now, that is confusing because it doesn't mean 1 over f of x, like this exponent typically means. So this is just kind of a notation thing. But I know it's going to be introduced sooner or later, so we might as well just start getting used to it now. OK, so this first example asks us to show that these two functions given here are inverses of each other. So what we'll do is just find these compositions and hope that they're both equal to x at the end. So if we start with, so f of x is 3x minus 4, and g of x is x plus 4 divided by 3. So let's see what's going on. F of g of x, so remember how we do this. We take f, and everywhere we see an x in the expression for f of x, we replace it with g of x instead. So we'll get 3 times g of x minus 4. And now let's remember what g of x's formula is. That's x plus 4 over 3. So we have 3 times x plus 4 over 3. And then from that, we'll subtract 4. And so the 3's cancel here. And we're just left with x plus 4 minus 4, which is just x. OK. OK, let's go the other way. So let's start now with f of x and then do g of that. So g of f of x should be, we'll take the expression for g of x, and everywhere we see x, we'll replace it with f of x. So we get f of x plus 4 divided by 3. And now let's remember what f of x is. That's 3x minus 4. So we have on the numerator 3x minus 4 plus 4. And on the denominator, we have 3. Well, plus 4 and minus 4 cancel. And we're left with 3x over 3, which is just x again. OK, this is good. So another way to think of this is to say, what does f do to x? And what does g do to x? And then from there, you might kind of think about how the two functions are sort of inverses of each other, just sort of in word, in a sense. So f takes an x and multiplies it by 3, and then from that subtracts 4. So we start with x, then we multiply by 3, and then we subtract 4. So how do you undo multiplying by 3? Well, probably dividing by 3. And how do you undo subtracting 4? You probably add 4. And you do that in the sort of opposite order. So g of x starts with an x and then adds 4. That would undo the minus 4 part at the end. And then it divides by 3, which would undo the multiplying by 3 that f does. So I think we'll see that a couple more times as we go here. But we're going to move along. So if you're given a function, f of x, and you want to know, what its inverse is, there's a kind of standard procedure we like to call like switch and solve. So you start by writing y equals to f of x. And then you interchange the roles of y and x, right? Because what's going on really with inverse functions, we have g, so we start with f of x, and the inverse function f inverse of x, this one has that its domain is the range of f of x, right? Once we do f, we land in the range of f. And to undo that, we'll start in the range of f to go back. So there's this kind of interchanging of the domain and range. So we'll see that again when we look at this picture here coming up. So to find the inverse function, we'll write y equals f of x, and then we'll swap x and y in that equation and solve for y. And that new y that we solve for will be the formula for f inverse of x. So let's see what's going on. So we have here f of x equals to 2x minus 3. So let's let's first start with y equals to 2x minus 3. And now let's interchange the roles of x and y. So we have x equals to 2y minus 3. And now let's solve for y. We have what? We can add 3 to both sides, and we get x plus 3 is 2y. And then we can divide both sides by 2. We get y equals to x plus 3 over 2. And then that expression is going to be the expression for f inverse of x. So you can see here in the picture that we've graphed both of these guys. And notice that there's a little bit of symmetry here, that there's reflective symmetry here across the line y equals x. So that is no coincidence. This is always the case with inverse functions. So if f has an inverse, its inverse function will be, it will have symmetry with it across the line y equals to x. And again, this has to do with the fact that the domain and range are interchanged. So the range of f becomes the domain of f inverse, and the domain of f becomes the range of f inverse. Okay, and so again, we can think for this example, we start with x, and f of x first multiplies that x by 2 and then subtracts 3 to it, and subtracts 3 from it. So looking down here at the bottom, I know I skipped this. We'll get to it in a second. So f will start with an x, multiply that guy by 2, and then subtract from that 3. And so notice the sort of operations to go from x to f of x happen in this order. And so then how are we going to undo this? Well, we'll undo each step at a time, starting from the end one. So how do we undo this subtracting 3? We'll add 3. So f inverse will start with an x and add 3 to it. And then how will we undo this multiplication by 2? We'll divide by 2. And so f inverse then takes that x plus 3 that it had and divides by 2. So, okay, and then one last thing we can notice here is that both of these guys are lines. The first line has slope 2, and the inverse function's line has slope 1/2. That might not be a coincidence either, that those two slopes are reciprocals. Okay, so here's another example. We have f of x is the square root of x minus 3. We'll graph both f and f inverse on the same pair of axes. But let's first find the inverse. So if y is the square root of x minus 3, now let's interchange x and y. So we'll write x equals to the square root of y minus 3. And now to solve for y, the first thing we want to do is square both sides, right? And so we'll have x squared equals to y minus 3 now. And now to solve for y, we just add 3 to both sides. And so we have y equals to x squared plus 3. So that is our f inverse. F inverse of x is x squared plus 3. And so we've graphed them both here, but notice what's going on here. We've left off half the graph of x squared plus 3, right? And why are we leaving that off here? Well, notice that the outputs of the square root function are only positive numbers. So really, we need to do some kind of restriction of our domain here for the inverse, because the inverse function is supposed to have that its domain is the range of the original f. And so we'll actually need, I should have probably written that on here. I wonder if I can't annotate. Let's see how this tool works. Probably not so well, but we'll just take it. So really, we should write here that really we need for this guy, x is bigger than or equal to 0. Boop. Okay. Because in the original one, we had that y was always bigger than or equal to 0. Okay, that was fun. So again, maybe we should think about this from just sort of like the standpoint of what happens to x. And again, we can see that these graphs are symmetric about the line y equals x. That's beautiful. But let's think about what happens here in terms of start with x. So f of x, it takes an x, first subtracts 3 from it, and gives you x minus 3, and then takes the square root of that. So how do we undo that? Oh, here, look at this. Well, hold on a second. Okay. So how do we undo this operation? Well, we'd first want to undo the square root, because that was the last thing that happened. So it's the first thing that we'll undo. It's kind of like you first put on your socks, and then you put on your shoes. But then when you're undoing that operation, you first take off your shoes, and then take off your socks, right? So, so the first thing that we'll undo is this square root, which we undo by squaring. And then the next thing we'll undo is this subtracting 3, which we'll undo by then adding 3. So I think this is a nice way to think about inverse functions and how they're working and what's going on with that. So let's see, maybe a couple more examples here. This function a of x equals to x squared. That gives us the area of a square where x is the length of the side. So here, this really only makes sense when x is positive, right? Because we don't have, if x was 0, we'd be in trouble. And we wouldn't really have a square. And if x was negative, that's not really a very sensible way to call the length. So we'll just consider positive x for this. So they ask us to find the inverse function of a of x. So what we'll do is we start with y equals x squared, interchange x and y, and then solve for y. We get y is the square root of x, right? That's the thing that undoes squaring, is taking square roots. And then they ask us to find the value of a inverse of 25 and interpret. This is probably the most important part of this question, is interpret. We have to do a little bit of thinking and turning the mathematical poetry into some ordinary human prose, right? So what is the meaning? Well, first let's compute a inverse of 25 will be the square root of 25, which equals to 5. And what does this mean? Well, this means that in a square whose area is 25 has side length equal to 5, right? X is the outputs, or sorry, the inputs of a of x become the outputs of a inverse. So, and also the outputs of a, which are areas, become the inputs of a inverse. Sorry, I studied there for a second. Okay, so let's do one more. The amount of water in a tank is given by the function w of x equals to 1200 minus 30x, where x is the number of days since the tank was filled. So we'll find the inverse function and interpret its value at the value when we input 900 to it. So we have our original function w. We'll write y equals to 1200 minus 30x. And we'll interchange the roles of x and y. We get x equals 1200 minus 30y. And now we'll solve for y. I don't like having the minus sign out front of the thing that I'm solving for, so I'm going to add 30 to both sides. And so I have 30y plus x is 1200. That means 30y is 1200 minus x. And so now I can divide by 30, and I get y is 1200 minus x divided by 30. And so that will be the formula for w inverse of x. Okay. And so what is this w inverse of 900? Well, let's see. We'll get 1200 minus 900 over 30. That's 300 over 30, which is 10. 10 what's? Well, let's see. 10 days, I think, right? The inputs of w are days, and the outputs of w are gallons. That means that the inputs of w inverse are gallons of water, and the outputs of w inverse are number of days since the tank was filled. So what we can say here is that the meaning of w inverse of 900 equals 10 is that when there are 900 gallons of water in the tank, it has been 10 days since the tank was last filled. So I think that concludes this section about inverse functions. And in the next coming sections, we're going to meet two new kinds of functions that we hadn't met yet. And these two new kinds of functions are going to have the property that they're inverses of one another. So stay tuned for that. It is not to be missed.